So the spherical coordinates is very useful to solve physics problems. So we need to find the velocity unit vector and acceleration unit vector. And these are the unit vectors for the position of spherical coordinates. We are taking our head and we will differentiate it with respect to t. And here, theta and phi are functions of t, so we must focus on chain rule. When we differentiate this term, we will differentiate sine theta, and this will be theta dot cosine theta cosine phi I hat, and then we differentiate cosine phi, which is minus phi dot, and we will write sine theta as it is times sine phi I hat. So this for I component. For j component, we differentiate the first thing, sine theta, have theta dot cosine theta times sine phi j hat, and then we differentiate sine phi, so we have phi dot sine theta cosine phi j hat. We go to k component, and this will be just minus theta dot sine theta k hat. To simplify this expression, we will take the terms that have theta dot and take theta dot as a common factor. Theta dot times cosine theta cosine phi I hat plus cosine theta sine phi j hat minus sine theta k hat. And in terms of phi dot, we will take phi dot as a common factor, and then leave sine theta sine phi I hat plus sine theta cosine phi. And this will be j hat. So the first thing, theta dot, this thing is so familiar, is just theta head. So we can write it in that form, plus phi dot, and we can take sine theta as a common factor here. We're left with this thing over here must be minus sine. So minus sine theta, minus sine phi I hat plus cosine phi j hat is just phi hat. So this is for r hat. Same thing for theta hat. D theta hat by dt equal. Take the derivative of cosine theta is minus theta dot sine theta cosine phi I hat, and then minus phi dot cosine theta sine phi I hat minus theta dot sine theta dot sine theta sine phi j hat. Then will be plus cosine theta phi dot cosine theta cosine phi j hat minus theta dot cosine theta k hat. And the same thing, we are taking minus theta dot as a common factor. Minus theta dot times sine theta cosine phi plus sine theta sine phi plus cosine theta is our head. And for the rest, we can take phi dot cosine theta as a common factor. I'm left with minus sine phi I head plus cosine phi j head, and this will be phi head. The derivative of phi head. So we are differentiating this. Minus phi dot cosine phi I head minus phi dot sine phi j head. We can take minus phi dot as a common factor, and we will see that weird expression here. We want this expression to be in terms of r head, theta head, phi head. But this thing is not similar for anyone for these. So we are doing a trick to find this expression in terms of the spherical coordinates unit vectors. The trick is we are taking these two. And multiplying here is times sine theta, and here times cosine theta. So this will be square, square, and sine theta. This will be cosine square, and cosine theta. We sum them to both. So sine theta r head plus cosine theta theta head equal. These two we can take cosine phi as a common factor, and we will live with sine squared theta plus cosine squared theta is just 1. So we have cosine phi I head. Here also, taking sine phi as a common factor, sine phi j head. And these two are the same but with different signs, so these cancel out. This thing here is that big. So we can take this and substitute it in our equation. So d phi head by dt equal minus phi dot times sine theta r head plus cosine theta theta head. And this is our solution.